and I would like to show you the working model of the Python notebook. So let me go ahead to that and then come back to the final project. So coming to this project, I have used the Python collab as I have already mentioned. So I have imported the libraries. After they get executed, I have got the top three records. As I have 5,111 records, so I cannot display the system cannot support it. So I have displayed only the the top three records of my database. Sorry, of my data set. And coming to the size, I've already mentioned that I have 5,111 records and 12 columns. And the columns are ID, gender, age, hypertension, heart disease, and so on. And this is the information that I have. Almost all the columns that I have are not null, and they are mostly of this type of int, float, and object. And then coming to the we have some missing values, so we have removed some of the values and we have updated it again. And coming to the numerical features, we have in order to work on the age, average glucose level, and BMI, we would require the numerical data. So we have updated it accordingly. And I have found out that the numerical features, by using the numerical features, I came to know the accuracy, the exact picture of how the age and the average glucose level looks like, and also the BMI. So I found out somewhere around somewhere around 250 to 1,750 records. So I found out that 20 to 50 years of age group has been affected, and this is the shatter plot that determines the thing. And then coming to the rank and correlation can be found out here. So, and then coming to the categorical features, like individually how the gender, how the hypertension, and how the health disease, I mean how the heart disease and the uh, type of work they do, and are they mean married or something. And then the residential type and smoking status. We would like to compare all of these into a one, and we would like to predict the occurrence of the stroke. And based on this frequencies, we find out that there are a lot of non-occurrences of stroke than occurrences of stroke. So I found out that there are 249 records that I have occurrences of stroke. So the percentages of stroke that my project shows, that is 4% of overall. And I would like to also take the plot target distribution for that, and also BMI, and normalization can also be done. If I do the normalization, I came to know that there are some high BMI levels that would indicate. And this is how my project runs. And the heat map also shows you that the age groups, the age of a person that is the highest is comparison to the other factors. So from the heat map, we can find out that the heart diseases, hypertension, and average glucose levels have been equal values. And then coming to the distribution plot, there are multiple plots that I have used for this project. And then I have taken the individual graphs that would determine, and now I would like to compare no stroke with stroke by the BMI. We found out that the BMI is most important here, and comparison to the no stroke by average a- a- uh, average glucose level, and also no stroke versus the stroke by age is being done like this. And we also found out some different representations and visualizations that this Python can do. And then I have done all this visualizations using the NumPy, Pandas, and Matplotlib libraries that the Python would support. And then the conclusion is that all the multiple visualizations are going through all the performances, and I would like to tune the hyperparameters with the help of the grid search to get the models. After that, I would like to compare the random forest classifier is the best model for this data set. Coming to the just overview of my project that I have done for so far. This is the introduction and this is the data set that would cover, and then the research problem for the data for the stroke prediction, and then the strategy development, uh, KI nearest neighbor and decision tree. And then this is the proof of work. I mean, the complete Python code that I have used. I have just saved it here so that I can review them whenever I require them. And then this is the complete Python code that I have used for this project. And then and this is where I can find out the most accuracy. And after doing the cross validation, came to know that the random forest classifier is the best fit. And this is the description that determines that. And then the outcomes are here. And then the, I mean, the Tableau outcomes are here, and for the Python outcomes are here. And then the future work, and then the conclusion, and then the references. Thank you so much for listening to this, and I hope you like this. Thank you.